All right, as promised, we are going to take a look at the Unit 1 review for Part 2 of our test that's upcoming tomorrow. Again, I'll try and show as much work as I can in places, but there's also some lessons, reviews, and things also as we went along in this unit with quizzes and quiz previews that you could also look back at as well. And I also have this key online if you just need to check out some answers and see some work to things. Okay. Since we just did factoring review again in depth in class today, I'm just going to mention a few things here as we go along. One, I notice here on this first one, two terms, nothing in common, but I notice they're both perfect squares. So, what do I square to get 25? What do I multiply by itself? That'd be 5. What do I multiply by itself to get 49? That'd be 7. And as we spoke about before, if you're multiplying two numbers and you want to get a negative, you need to have one of each sign. And again, the order doesn't matter. You could have minus 7 plus 7, no big deal. Okay. Now 2, a little more interesting. Because I notice here, ooh, yeah, nothing goes into all three of those. So now again, at this point, I'm in one of two modes. I can either play guess and check, or I can go slide and divide, which many of you choose to do. So if you go that route, and I will do one of the guess and check ones on one of the ones a little later along. Again, I'm going to multiply that 8 down to the end, and then if I have to, and again, we talked about this in class when we did the little mini factoring review, so I'm not going to do it again, but if I'm not sure what multiplies to 120 and adds to negative 26, I know a couple of things. Well, what do I know? Well, I know that since they multiply to get a positive number, they're either both negative and both positive. Well, how do I know which one it is? I can even tell you that right now. Since my sign in the middle is negative, that tells me that both of these are going to be negative values. So basically what I'm looking for is two numbers that add up to 26 that multiply to 120. And if you don't know, you may have to do what I'm doing right here. And basically, with a calculator, you do 120 divided by 2. Oh, that went in evenly. Write it down. Divided by 3. That went in evenly. But I haven't found any that are going to add up to 26 yet. So I just keep doing this. And I'm going along here. And I'm like, really, Harty? Another good reason to learn more with your multiplication facts as you go along. Okay, there's my 2 that add up to 26. Now, you're not done. This is not strictly a diamond. This is slide and divide, and all we've done is slide so far. So then we divide by that original number that we slid down. You have to reduce the fractions. Now again, if you want a complete breakdown of how to punch in the things and break down a fraction, you're going to want to go back to Factoring Revisited, which is either on my website on the Monday, or you can go to my YouTube page at Harty Math and watch the Factoring Revisited. So when this reduces all the way down to its simplest value, it'd be 5 over 2. This one would be 3 over 4. Neither of them turn back into a whole number. So at that point, I can take the value and work it back to the front. So the 2 slides back becomes 2x minus 5. The 4 slides back to the front, becomes 4x minus 3, and I'm done. And I can even FOIL this out if I'm not sure. Asking me isn't going to help you on the test. 4x times 2x is 8x, that's good. Negative 6 and negative 20 is negative 26. And negative 5 times negative 3 is 15. All right. Let's see. Can I do the golden rule on number 3? I think I can. I think I can get a 9 out of each of those, and they each have an x. So what have I got left? Let's see. 9 times 4 gets me to 36. I've got an x. I need to get to x squared, so I need another. And then you're like, well, do I just put nothing because it's already 9x? No. What can you multiply by itself to get anything? And that's 1. So I'd multiply it through, and I'm good to go. For those of you that like your diamonds, here's your chance. I need two numbers that multiply to negative 90 and add to positive 1. Again, clues galore here already. Multiply to get a negative. I know one's negative and one's positive. I also know that when I add them together, I'm going to get a positive 1. It means my positive number has to be the bigger one. Because if you take a positive and negative and add them up, whichever one has the larger value, we want that sign. So I'm like, okay, they need to be one apart. And again, you may have to start going and dividing in until you find something that works. For some of you, that may be quick. For some of you, it may take a little while. Those are one apart. The bigger one's the positive one. X squared plus 10x minus 9x, so 10x minus 9x is a positive 1x, and negative 9 times positive 10 is negative 90. I'm good. Okay. Here, again, you can do slide and divide like we did up in number 2, and it's still there, so you can kind of see how it works. But if you wanted to do the guess and check method, okay, maybe you get tired of doing the work with slide and divide, and you think you can make this work. Well, what multiplies to 5? I don't have many choices. It's 5 and 1. So 5x and x. 6, though, I have choices. So this is one of those times that you want to do one of a few things. If you have a pencil available, because I would not do this with a pen, what you can do is I now can look at my 6 and I can say, okay, 6. It's either 1 and 6 or 2 and 3. All right, what do I know? I know there's going to be one positive and one negative, but with that 5 there now, it's going to make a difference on where it's at. So I might have to mess with this a little bit. But my big thing here is to keep in mind, okay, I need 2 numbers and I want to get to the 7. So let's say I try 1 and 6, okay? Before I even worry about signs, I get 30x and I get 1x. Is 30 and 1 going to get me to 7? Well, no. Okay. Can 5 and 6 get me to 7? Well, no. Okay. And some of you are probably frustrated with this. But again, there's not many options left. What if I do 2 and 3? 15 and 2? Nope. Harty, did you purposefully do the one that works last? I'm not admitting nothing. 3 and 2. 10 and 7. 10 and 7. 10 and 3. That can get me to 7, though. So I want it to be negative. So I want my larger product, the 5 and 2, which is 10, to be negative. So let's see. 5x squared minus 10 plus 3x would be negative 7. And 3 and negative 2 is negative 6. Guess and check can work, okay? But again, all on how you want to do it. And now this last one. Now some of you are going to go, oh my gosh, I'm trying to do slide and divide right now. And you want me to come up with 2 numbers that multiply, if I multiply the 9 down here, to 576 and add to 48. Are you crazy? I'm just leaving that one. You don't have to do all that work. Like, what? Look at the first and last terms. They're both perfect squares. Again, why do you need to know your perfect squares? A situation like this to make life simple. If you know those are both perfect squares, all you have to do, what do I times by itself to get 9? 3. What do I times by itself to get 64? 8. What are all the signs? Plus, woo, okay? Now, could I slide and divide that? Sure. Am I going to do it? Absolutely not. Are you crazy? I'm not going to make it hard when I don't have to. That'd be silly. Okay. Now we finally get past factoring. Okay, domain and range. Domain, x values, range, y. Domain, left to right. Left to right with x values. Negative 3. X value, come right here to my x-axis, positive 3. Done. And yes, you need the brackets. We're including those points. My range is my y's. From bottom to top. From bottom to top. From negative 4 to positive 2. And is it a function? Does it pass the horizontal line test? Is there any place I could put, the vertical line test? Wow, I'm jammering and yibbering here. As I look, it never goes through my graph in more than one place. So yes, it passes the vertical line test. Vertical. Horizontal is for our one-to-one testing. Okay, now fancy language. Describe how the graph of each function is related to the graph. In other words, what are the shifts, if there are any? Inside the absolute value is my left and right shift, but it's the opposite of what you think it is. Because again, when I'm doing these, x minus h plus k, hk is my vertex. So this is the opposite. The opposite of negative 4 is positive 4, which would be right 4. Because again, inside my absolute value are my left and right shifts. My up and down shifts are outside. So on this one, we get to do both. Plus 3, again, it's the opposite of that, which would be minus. So that's left 3. Outside is my up and down. It's negative, so that's down. And this one flips because of the negative. Means my v, instead of opening up like it would be on 8, is now going to open down. Okay? I got to have all of that. Those are all things that shift or move my function. So that's just something I've got to do. Name the vertex for each equation. We talked up here about what the vertex is. Now I'm just going to take that straight from the equation. Like, but I don't see a number there. Okay. Remember, if we don't see a number there, it's like having 0. So my vertex here would be at 0, negative 6. Again, it's x then y, and that matters. You're like, well, how am I going to do the graph from here? Okay. I'm not bothering with the calculator. That is not necessary for these, really. As long as you take one value that's one less and one that's one more, and the cool thing about these absolute value graphs is they're symmetrical. So once I plug one of these numbers in, I actually have both the answers. Don't tell anybody. So with the 1, if I plug it in, the absolute value of 1 is 1. 3 times 1 is 3. Minus 6 is negative 3. And that would be the same for both of these. So I'll plot those 2 points. And then I'm just going to make a big old V. And I'm done. Don't make this more complicated than it needs to be. Hey, here. Again, it's x minus h, so it's the opposite of this value. But since that's plus, I just keep that one. So negative 4, 2. This one's going to be opening down because it's negative. And remember, I don't even have to chart these. Because some of you might be looking at this and going, well, wait a minute, I remember we did the charts at the start, but then didn't we start doing slope? Yes. As long as I can keep my slope straight, 1/3. But again, it's negative, so it's my rise is 1, so I go down 1, and my run is 3 each direction, so down 1 and right 3. Can I do the chart? Sure, but it's much easier to just do the slope, because you'll even think back to number 10, my slope was 3 over 1. 1, 2, 3, 1. 1, 2, 3, 1. Okay? Last one. Switch this value, because it's minus h, is 3, negative 5. Which way is it going to open? Positive value in front. For my a, it's going to open up. My slope's 1 over 2. Up 1 and right 2. Up 1 and left 2. And I'm set. And again, the nice thing with this is if I start going too fast, you can pause me, rewind me. If I say something silly that you want to listen to a couple times, you can. But again, I'm just going to kind of try to keep rolling along here. All right. Write the equation for the graph in this form. We're going to give you the form. Remember, that's like our slope, but we got to watch for negatives and positives depending on which way my graph opens. And then the h and the k is just my vertex value. So I need those two things to be able to solve this. Well, there's my vertex. My vertex is at 2, 1. There's my h and my k. And my slope, I notice a couple of things. First, it's negative. Why? It opens down. So to get that, okay, I go down 2 and over 3. 1, 2, 3. Okay? So I got my slope. So then I just make the equation. A is my slope, negative 2/3, x minus my h value, which is the x value of my vertex, plus k. Bang. So as long as you know the vertex and slope, No biggie. Okay. Write in radical form. Don't simplify. Okay. Remember with these, and that's true on either of them, this is exponent over root. Okay. The exponent's on top, the root's in the denominator. Okay. Exponent over root. When I go to exponent form, I just do this. I go, okay, the exponent's 7, my root's 4. Now let's see. My exponent's 9. Oh yeah, now let's see here again. What's my root when I don't see it? No, it's not 1. No, it's not 0. It's 2. And again, that's all I'm doing. I don't want an answer. I don't want a decimal. I don't want anything fancy. Just want the different forms. And again, you'll also notice on these as you're working along, it'll mention section numbers. And when I put my sections, both in the notes and with the YouTube videos, I also put section numbers. So if you're having trouble with something, you want a little more in-depth analysis, there's a good place to go. Okay, simplify, leave an exponent form. When we're multiplying, we add the exponents. Now, it's not quite as simple as just doing 4 over 3 plus 1 over 6 and adding across and calling it 4 over 9. No. We must have a common denominator. Now, common denominator, if I count by 3s and count by 6s, I'm going to get to 6 pretty darn quick. So my 6 can stay the way it is. My 4/3 though, and if you're not used to messing with these, trying to figure this out, I need to turn thirds into sixths. So 3 times what gets me to 6? 2. And I do the same thing up in the numerator. So that becomes 8 over 6. 8 plus 1 is 9 over 6. Notice the denominator didn't change. But if I can reduce the fraction, they're both divisible by 3, I need to do that. Now, worst case scenario, could you type 4/3 plus 1/6 in the calculator and hit math, enter, enter, and get that? Yes, but you still have to know that you're adding the exponents. When I'm dividing, you subtract. Okay. My common denominator for this one is going to be 15. Now, both of these need to be turned into something over 15. So, I go, all right, do my side work. This is something that pays off later because I remember how to do mental math instead of having to go to my calculator all the time. So whatever I do down below, I do up top. Same here. So I got 35 minus 6 is 29, and we're good to go. And then we save the easy one for last. On this one, oh, excuse me. Back up to our buddy here, exponent over root. Exponent over root 27 divided by 3 is 9. Again, coolness. 21 and 22. Now I'll do one of these each one way according to what we did in class, just in case you want options. Some of you like doing the shifting and don't want to mess with the calculator. I'm good with that. We talked about our base graph, which is just the square root of x. And we talked about how if you knew the base values, again, perfect squares showing up again, I tell you they're going to keep showing up. And I take the square root of each of those. Those would be my base points. So I have a base point at 0, 0, 1 at 1, 1. I'm not going to be able to fit the 9, 3. But I'm just using a pencil. Or if you use a pen, just do it light. Because then what I can do is I can say, okay, what are my shifts? Just like when we were doing the absolute value graphs, it's the same idea. So left 3 and down 4. Okay. So left 3 and down 4. And I'm just going to shift each of those and connect the dots. Notice I'm not connecting the dots here, and if I did it in pencil, once I get done, I'll erase it. But that's how I can do it without a calculator. Plot my base points, and then just do my shifts. Now, if just watching that makes you go, yeah, okay, here's your option if you want to go to the calculator. All right, we'll get that cleared out. So I've got a negative. Again, square root is second and x squared. Whatever's under the radical has to be what's in parentheses, and you have to close them. If you forget it, it's not going to work right. Plus 5. Okay, let's make sure it looks okay. It opens down because of the negative, and let's see what the shifts were again here. It would be right 1 and up 5. So does my initial point look like it went right 1 and up 5? It does. But let me get, and remember, oh yes, the one with the errors. Right. Wherever I see error means my graph's not going there. So I don't want to put arrows on that end. So my first point, oh yeah, right 1 and up 5. Because we talked about how if your initial point starts at 0, you go right 1 and up 5, but that's also the first point I see on my graph. I also see one at 2, 4, and 5, 3. Looks like the last one that'll fit here. And again, not arrows on both ends, just going to the right. You put arrows on both ends, feel the wrath. And finally, getting to the back here. Describe the transformations, again, fancy word for shifts, that change f of x into g of x. Okay, let's see. I see the negative. Means we've got a flip working. What's the minus 4 inside the square root mean? That's right. We're going right 4. Because remember, it's x minus h. Whatever it's in the inside is your left or right, but it's always the opposite of what you think. And again, if you want to break down total detail, right there. Okay, no flips this time, but I have a shift left 3, and I have a shift down 1. Okay, got to have them both. Here, let's talk about this first. Okay, so we got the up 3 because it's not under the radical. Be careful. Well, what's the 5 do? The 5 stretches, or in this case, since it actually makes it smaller, we could say shrinks 5. It changes the value, it changes the width of my graph. And then finally into some of the stuff we had here at the end. Okay, solve for x by showing all work. Remember, that root of 2 we talked about earlier, that's important here, because if it's a square root, the inverse of that is to square it, and that's to both sides. You're not squaring everything underneath here, you're just on the left, the squared and the square root just take care of each other. Again, it's 9 squared, not 9 times 2. Subtract my 6 and divide by 3. And you always want to check your answer just to be sure. 3 times 25 is 75, plus 6 is 81, and the square root of 81 is 9. Okay. Over here, we must always isolate what's underneath here. So what do I have to do first? I got to get that minus 3 out of there. Okay. So 4x plus 1 to the 1/3 equals 7. Now, when you have an exponent up here, to take care of that, we want to get it down to 1. We want to make it go away. We use the reciprocal power. So if you take 3 over 1 and you flip it, you end up with 3 over 1, or 3. And again, both sides. On the left, the exponents cancel. That's all that happens there. 4x plus 1 equals a really big number, 343. And now just solve it. Subtract the 1 over and divide by 4. And yes, getting a decimal or a fraction is okay. But those are the only things you have to keep an eye out for. If there's a different root number, if it's a root like this was to the 4th root, you take both sides to the 4th power. If this were to the 2/3 power, you take both sides to the 3/2 power. It's the inverse. Okay? That's all we're doing on either of those. And then again, circles, which we took a look at before our last quiz. When we're looking at circles, again, and you start to notice this H and K thing comes up everywhere. Yes, it does. Okay. My center is going to be at HK. So my center, ooh, it's opposite on both because it's minus. So switch the signs on both of those. That's my center. And my radius, since that's r squared, is just going to be the square root of either of those. And that's all you're being asked to do here. Ooh, what if I don't see something there? I know this is -1. Again, we know that that's the equivalent of having a 0 there. Can't change the sign on 0. And again, the radius is just the square root. And we're set. Now again, down at the bottom, and this is becoming consistent, did this on the last test too. You need to know where you're weak right now. If you watch this video and just had a blank paper and just writing everything madly, you are not ready for this test. If you went and did most of the review and there was a few questions you did here and there, okay, that works pretty good. That's where, again, I'd go back to the sections and find the odds maybe so you can check some answers. Or maybe take some answers from an old homework check or an old quiz that looks similar and see if you can do them without looking. Or maybe even look at your answers and kind of work backwards to see how you did it. But you've got to put in the time. If you don't put in the time, you're not going to get the results on things. If you don't practice it, you don't get better at it. And if it's something you struggle with, again, you've got section numbers here. Look at the notes, look at the videos, ask a question, whatever you've got to do. But be ready for this, because again, tests are huge, and with you only being able to retake one a semester, you got to make sure that this is not that bad one. So good luck, and hopefully this pays off for you. Study hard.